Greetings and welcome, friends. Algebra 1, am I right? We're in the meat of it now. This is 1.1. We're on page, what was it, 8? 16? 8? 8 from our Big Ideas, Common Core, Algebra 1 textbook. Here I'm giving you a flavor of solving simple equations right here. So what I've got here is a couple of equations. We were asked to solve these top two. To solve an equation means to determine the value of the variable that makes the equation true. Now you might be able to guess that. And I think that's a skill that's valuable. It's good to be able to kind of like just be like, oh, does this make sense? Can I figure this out? But today, I'm interested in teaching you a process, right? It's kind of like I want to train you to be a ninja, and I'm just giving you like a simple little sparring partner, and you're like, oh, look I just like conquered this battle by tackling this guy. And I'm like, yeah, I understand you could just tackle this little kid that I had you spar with, but I'm interested in teaching you how to punch. Not that you should be punching little kids, but sparring. I want you to be a ninja. And that's what I need to train you to do. So don't just like try tackling these problems with brute force. Learn the process so then you'll be a punch master someday. You'll go like Chuck Norris on these algebra problems later on in the year. So here we go. I've got -14 equals p minus 11. In order to solve this, I want to get the variable by itself. So currently, p is being subtracted by 11. So to undo subtraction, I'm going to add. I'm going to cancel that out. So if I add 11 here, that is the inverse operation, is sometimes what that's described as. So -11 or subtracting 11, its inverse would be to add 11. Now, if I just add 11 over here, it's no longer going to be equal, right? Like I just unbalanced my equation. So I actually have to add 11 to both sides of the equation. And so what I'd end up getting is -14 plus 11. Signs are different, so I subtract them. 14 minus 11 is 3. Take the sign of the more influential, which is negative, equals p. And then let's just flip this around because I think it makes more sense when I read it from left to right this way. P equals -3. Now it is possible to do what's called a check, where if this is actually equal to -3, then I should be able to plug it in there. I didn't ask you to do checks last night, but tell you what, let's just do a quick check right now. Is -14 equal to -3 minus 11? And when I do a check, sometimes people, I've seen this, friends, they'll go back to doing algebra. They'll be like, oh, I'm just going to add 11 to both sides. And then that's actually not a true check, because what if they make the same mistake twice and then get a false positive where they assume they did the problem correct, but they actually just made the same mistake twice, which didn't expose that they were wrong. When you do a check, what you do is PEMDAS. You're just doing regular old order of operation. Which, by the way, PEMDAS is going to show up in today's lesson. So when I do PEMDAS, -3 minus 11 is becoming more negative. I add the numbers and I keep the sign. -14 equals -14. So cha-ching, it seems to make sense. That is the value of p that makes the equation true. So that's what I'm interested in. So okay, so over here, question 25, similar setup. I want to solve for the variable r. I want to get r by itself, or isolate the variable, as we say. Is r being subtracted by 8? Is that what's happening here? No, that's not subtracted by 8. So I can't solve this by adding 8 to both sides? You're telling me? That won't cancel out? No. What operation is happening to r? R is being what by -8? It's implied here. It's multiplication. That's right. So the inverse of multiplication, the undo procedure for multiplication, is division. So the inverse of multiplying by -8 would be to divide by -8. And if I do it to the left-hand side, I got to do it to the right-hand side. Some people call this the golden rule of algebra. They say do unto one side of the equation as you do unto the other. I don't know if you guys have heard of the golden rule thing before, but there you go. I've heard this referred to that. So let's see. Notice the benefit here is, right, when I did an inverse operation over here, these would cancel out and I get the variable by itself. Over here, 8 and dividing by -8, those cancel out. A negative divided by a negative, those cancel out, become positive. I would truly get the r by itself, which is what I wanted. R equals, and 64 divided by -8, is that going to be positive or negative? One minus sign, it doesn't have another one to partner up with, so it's still negative, and 64 divided by 8 is 8. Okay? And if I wanted to do a check, I could. I'd plug -8 in here, and actually, I was going to skip this check, but then I realized this is actually a valuable one to do. Is -8 times, and instead of r, I'm going to write -8. Notice when I do a check, when I substitute, I use the parentheses here, just so I don't make a mistake, because I didn't want to accidentally interpret this as -8 minus 8. It's being multiplied. And -8 times -8 is positive 64, so it checks out. All right, last question. This one is error analysis. It says, describe and correct the error in solving the equation. Okay, so here we go. Let's see. I'm going to take out my red pen here. Oh, it's already been marked wrong. So here's the original problem. M is being divided by -3 is one way I could think about it. You could think of this as 2 steps. M is being divided by 3 and then multiplied by a negative, whatever. Either way works. And so to get rid of the 3, the divide by 3, the inverse operation is to multiply by 3. I like that. Okay? And did they do that over here as well? It appears as they did, right? -4 multiplied by 3. I like this so far, friends. Now, what happened between this step and this step? Does anyone spot the error yet? Well, the 3 here would cancel out with a 3 here. And the issue is that this minus sign still exists. I would still have a -m here, or the opposite of m, as sometimes mathematicians are very particular about. I'm fine if you call it -m myself, but they'll say the opposite of m because what if m was already negative, and then the opposite, or negative of -m, would be positive. So yeah, opposite of m, -m, I know what you mean. So the issue is m does not equal -12. -m, or the opposite of m, is equal to -12. So they even did this multiplication correct. 3 times -4 was -12. So the issue was they didn't deal with this sign. So you actually have an option now to deal with that sign. You could view that as -1m if you want. So you could divide both sides by -1. It's just going to opposite both sides. You could multiply both sides by -1. That actually accomplishes the same thing. That's fine. But we do have to do one more step. Or I'm even fine if you guys are just like, just opposite both sides. If the -m is equal to -12, then surely positive m is equal to positive 12. All right, so that's the correction. So the issue was, let's see, here was the issue right here. That doesn't show up at all. They didn't account for the minus sign, right? Or the negative, right? That was their issue. One way to do this, instead of making this a 2-step problem, if I have -m divided by 3 equals -4, does anyone know how to do this all in like one punch? Just like, and take this problem out? Well, no, I don't want to move this 4. Because remember, when I'm solving, I want to get the variable by itself. So I actually want to get everything away from the m. So I'm actually happy where this -4 is. Well, the operation in play is division. This minus sign is just saying, well, yeah, multiplying is what they did, and I agreed with that step. But to do this all in one fell swoop, I could actually multiply by -3 on both sides. All right, so multiplying by 3 cancels out the denominator like we showed here. If I multiply by -3, it will in one step also get rid of the minus sign. So the 3's swipe out and the minus signs swipe out. and in one move rather than two, I would have been able to get m equals negative times a negative, by the way, is positive 12. So I do, in fact, get the same answer. So the operation in play was not subtraction. That's not a subtraction symbol. That's, a negative symbol. It was division in play, and the inverse of dividing by -3 is to multiply by -3. So we're going to do some more practice today with inverses and whatnot. But thank you for watching, Internet friends. Have a great day.